Hello everyone. I'm Pranav Reddy Gaddam, and I'd like to present our project on network-based social media sentiment analysis on Twitter. Every day, over 300 million tweets flow in, full of opinions, slang, and emojis. We needed an end-to-end pipeline that can clean this noisy text, classify sentiment using both classical and deep learning models, and reveal network relationships in real time. So we went on to build models for this. So before building our models, we conducted extensive exploratory data analysis on our Sentiment 140 dataset. So let's look at how that looks like. First, we loaded the dataset using pandas, then cleaned them up using stop words. This is the clean text. Then we plotted a count plot for both the classes where the negative and positive tweets are an equal distribution. Then we checked for null values. We didn't find any. Then we drew up a distribution plot for the tweet length, which mostly is between 20 to 120 characters, peaking around 80. Then we went on to build our models. Here we did some feature engineering, drew up some unigrams and bigrams using the count vectorizer. Then we went on to build word clouds for the negative and the positive ones. The negative ones, as you can see, includes work, which most people don't like to do. And the positive ones includes words like love and thank you. And this is the daily tweet volume for the entire data set. And you can see most of the tweets were made in June and July, and some were made in August. Next, we divided the data set into training and testing with an 80-20 split. This is the model for logistic regression. We trained and tested it, then imported pickle to save it into a pickle file. As you can see, after training the model, we did some evaluation, calculating the precision, recall, and F1 score. The precision, as you can see, is 79% for logistic regression, the recall being 75, and the F1 score being 77. Then as we scroll down further, we imported another model, which is SVM, using the grid search CV. After training the SVM, we found out that the precision was 79%, recall being 78%, and F1 score also being 78%. We imported the pickle module again, I don't know why, and then put this into the pickle file. Moving further, we thought of moving to deep learning models, which is why we tried BERT. We tokenized everything to put it into BERT. This is the training part and the testing part for BERT. So we did some fine tuning by changing the batch size and the number of workers, that the number of threads change, or how the model uses the GPU. Then we trained it only for one epoch because it was very computer intensive and we didn't have a lot of GPU space, GPU power to do this. So after training the model, the average train loss was 36%. And after training it, we checked the validation report here as well. Here the precision shows 84%, recalls 86, and the F1 scores 85. It definitely performs better than the other two, as popular opinion goes. Then saved this model into Another pickle file, a JSON file here because deep learning models don't turn into pickle files. Then checked an ROC AUC comparison here. It has a very high AUC score of 92%. Then drew up a confusion matrix where we can see that the true negatives were 86.2%, true positives being 83.8. Now let's see all these models in action, where we built a Streamlit dashboard using Python, where we put all this into action. Let's see. Typing happy. Tweet shows that it has a positive sentiment. It has a confidence score of 99.36%. This is the confidence gauge, and this is just for the streaming processing. And if I wanted to do batch processing, I will go to browse file. I'll upload a sample CSV, load, and I will go on to run predictions. And these are just 10 random tweets that we picked from the data set. And all these get accuracy, precision, recall, and F1 scores. I drop a confusion matrix for all these. And then again, another classification report of negative, positive accuracy, match for average, weighted average, whatnot. And then we drew up an ROC curve for this. Now, as we move further, we can go on to see a knowledge graph where we can filter by username, filter by keyword. Let's say I put in the word happy again. I don't know, I'm feeling very happy today. Oops, that was not supposed to happen. Oh, that was the username, my bad. I need to filter it by keyword. Yep, we can see which users have commented happy. Now let's select this user called Kili. Now Kili has commented happy tweets with 3 other persons. Now if I wanted to actually see those tweets and what she commented, and if she was actually happy, the first tweet shows, I am happy because my parents acted that way. But it's not so happy for you, so she's not really happy here. And then Googling, and I thought I'd never be the victim. So let's see if our model has classified this correctly. So as you can see, it has mentioned not so happy and the sentiment as showing negative and the confidence score of 92.1%. So I think our model's doing pretty good here. Next, we can go on to deploy this on Streamlit Cloud, AWS or GCP for further enhancements. Uh, and other future enhancements include maybe turning to transformers like Distilbert, real-time trend dashboards, sarcasm detection, multilingual support, ideal for brand monitoring, maybe political analysis, crisis altering, and mental health research. That concludes our demo. Thank you for watching. The full code, report, slides are on GitHub. The link is below. Feel free to fork, improve, and reach out with your questions.